To my channel. If you're new to channel, please subscribe to my channel. Previous video we have started about collections. We have seen what are the collections we have, like list, queue and set, and we are going to go in that list collections. What are the three things like array list? We're going to discuss about array list, linked list, vector and others. So let's start about that. What is array list? Array list, it is homogeneous as well as heterogeneous in nature. Homogeneous as well as heterogeneous in nature. It allows duplicate and null values. It allows duplicates and null values. Insertion order is preserved and initial capacity generally it would be 10 and it will be growing. So let me show you one example of this array list. How we are going to I'm going to use this on Java compiler. So say array, or just let me choose another compiler. JDB compiler. We use this. Okay, it's loading, guys. Just a second. Yeah. Class, let me say main. Is it main? So I'll say array list. Array list. Equal to new array list. So we import it as well. Import java.util dot array list. So now let me say al dot add anything, something like name, like hello al dot add, say okay, next say like king al dot add, say 100 al dot add, I'll say some null value. Now if I add 100 one more time, now I'll print system.out.println print ln. So I'll say al. So if I see what it's going to print. So as you can see, it's printing this array list is printing all the values. it's not, it doesn't matter if you take number or integers, because this array list is going to print all the values whatever we are going to take. This a dot add is going to add this values into this list. So now if you want to check something whether this thing is there or not, or say print I'll say print ln. Now if you want to check al dot contains, I'll say 100. Let me make this 120. Let me run it. True. So if, as you can see, if there is any value present, it's going to print true. If it is not going to present, it should print false. Yeah, this is how it's going to we will check whether that value is present or not. It's just like find method. You check al dot contains, is going to print whether the value is there or not. Now I'll print again, print ln. Ln, I'll say, so I want to get at a position dot al dot get at particular position. We want to get some at a, like a, so if at a position of 1 what the value is present, that I want to check. So for that I point 1, its index is starting from 0, so that's the reason it's printing here king. Now in this, if you check, let me scroll up. So it's 0 1 2 3 4, so it index 1 king is present. Now if I print here 0, now again if I run it, at index 0 it's hello. Now index 2, if I print 100. So this is how it's going to check it. Now if I want to remove something, there is something called remove method, al dot remove of, let's say last index I want to remove, or I want to remove this null value, it's at position number 3, right? So we print at 3. If you run remove, and if you print after that that thing again, if you put and print it, or if you check it, so that null value is removed. See, previous null is printing, now null value is removed here. Now there is one more thing, like set method. Wait, let me show you. Dot set, let's say, let me say 3, this is 150, I'll take. Now if you run this, so if you see, not 3, I removed 3, right? Let me pick 2. So let me print here, setting it. If you check it now, so you see, previously it was like 100. Now at position number 2 I replaced it with 100, so it's printing 150. I replaced it with 150, 100 with 150, so it's printing 150. This is how this set method will work. Now I think yes, let me show how to add anything, like add your seed. So let me show one more method, like that I'll say size. You can get size from here. If you run it, see, size is 4. You can see 1 2 3 4, size is 4. So I'm going to print size 4. Now if I say there is one more thing like dot print al dot clear. Now I am going to clear this. Clear, and here I am going to print. I want to check whether is empty or not. Is empty or not. Now if I print it, see, when I do al.clear, this everything going to be removed from that al. So when I'm going to print this al.empty, it is going to check whether that al is empty or not. These are some built-in methods which we use in the collection, like in array list. Now this is mainly about array list. Now let me show you about vector. Now it it's introduced in JDK 1.0. It is homogeneous as well as heterogeneous in nature. It also allows duplicate values, and it also same thing. It's like it is also same point here as well. So let me it's heterogeneous as well as homogeneous in nature. It allows duplicate. It allows null values. Insert here the what do you say, insertion order is preserved. Same like previous one. Insertion order also preserved. Initial capacity is also 10, but the main difference here is this one, like initial capacity is 10, and it will grow half of its initial capacity. Initial capacity, I think it should be initial, yeah, initial capacity. Next again, initial capacity is also 10, and it will increase by double of its initial capacity. Double of its initial capacity. So let me show you an example. Same thing like this, whether instead of here array list, I'll say vector copy it, say paste vector. Same thing, I'll say al 100 contains 100, and dot get remove, everything will be same. Dot set, okay, this, let me check what is there still. So is clear, okay, everything would be same. Now if I run it, let me check what it meant. Oh, sorry about that, I think forgot to import that statement. I need to remove here array list. Here we need to put vector. Okay, now this should make everything's fine. So yeah, everything would be same. You see output here, hello king, like previously, hello king 100 120 100. This is how it's going to print. Now coming to next one, there's nothing much difference. Now the next one is bit important, guys. Focus on it, please. Now that is linked list. So it is as well homogeneous and heterogeneous as well. It allows duplicate and null values. There is no initial capacity for the linked list. Here is the main difference. I'll say there is no initial capacity for the linked list. The elements be stored in the form of node. The elements are stored in the form of node. Element is stored in the form of node. Node format, but there is one more thing is like, but one node should know where its previous element is stored. Element is present and where its next element is present. So it should be like, let's say, example of this, like there is one node, there is another node, this is another node, and so if you see this 1 2 now here I'll say it has value something like, say 10, some random values, nothing, don't worry about the values here, just go with the flow. So 10 20 30. So now what is the thing is, here this next value is connected to this and this previous value is connected to this next value and this value. So what I mean is, so this 10, after this 10, this node next value is going to present in here, address, this address is going to present in here, and this 20 previous node, that is 10 value address, is going to present in here. Same wise 20 the next value 30 address is going to present in here, and this 30 is previous value 20 is going to present in here. So there is a link between each nodes. This is how the linked list works. The reason it can connect with two ways, so that's the reason it's also called as doubly linked list. So let me show you one programmatic example about this linked list. Now just like this, I'll say here, instead of vector I'll say linked list just remove this and put, let me star. So now let me say add key, let's say 50, some let's say 80, contains 100. Same thing guys, nothing much different here. Dot get, say here return say 0, and 3al set, I'll say 3 comma 50. Here size, let me check, let me run it. Yeah, if you see, so linked list, these are the values stored, whether it's going to check, we are added these values. Now we'll check whether the 100 is present or not. What is the 0th element? Similar thing is nothing much different. Not too much difference in this. I'm just giving some basic examples of it. So next one is going to be Q. So let me just now everything, I don't want it now, nothing is required. Hope you got it previously what I have said. So now next new thing, like let's say priority Q. Now we are entering into another concept like Q. It is homogeneous in nature. Homogeneous in nature. So homogeneous nature. We try to insert a mixed object, we will get something like a class cast exception. So here null values are allowed guys. If we try to insert a values, we will get, if null values are not allowed, not allowed, if we try to insert the values, it is going to get null pointer exception. But here duplicates are allowed, and here insertion order is not preserved. It's going to be in binary structure format. I'll show you one example how it's going to be, how the priority queue going to work. So let's say, now before that let me add something like, sorry, so let's say we have values like 60, let's say 40, something like 30, and I'll say 20 comma 10, I'll say like something like 90. These are the things which we have. So if I'll say to this one, so first what happens is, like we have here $60 connecting to this, we have 40 here. So if you, now what happens is 40 is compared to 60, which one is smaller? So 40 is smaller, it's going to swap the positions. So in next one, see here, here we are going to get 40, and here we are going to get 60, and here we are going to get the next element, that is 30. Next element 30. So this one. So now what happens is, now it will compare with this 30 and 40, which is smaller. So 30 is smaller, so 30 will go to this position. So I'll say here it is going to be 30, here it's going to be 60. Here is going to be 40. The value going to be 40. Now if you check, everything is normal. So next 20 will be added in to the 60, this node here. So now 20 is added here. Next one 20. Now it's going to check 20 is less than 60, so it's going to next is going to start here. 20 will be coming here, 60 will be coming here, and again it is going to check 20 with 30. 30 is 20 is smaller than 30, so 20 would be jumping here and 30 would be moving to that position. So at top it's going to be top is going to be 20, and in here it's going to be 30. And here it's going to be 40. And here is going to be 60. And next value 10 is going to come, so 10 would be here. I'm just explaining how it's going to be, guys, so that you will understand the next coding. When I go to the coding, you will get understanding without any issue how the output is coming. So next 10 is less than 30, so it's going to swap 10 here, 30 here, and now 10 is compared with 20. Now 10 is less than 20, so it's going to swap here, so 10 would be coming here. So it would be like please adjust with the diagram, sorry if it's not good. So finally it's going to be like 10, and here it's going to be like 20, here is going to be like 40, going to be like 60, and here is going to be like 30, 10, this is 20, this is 60, this is 30, this is 40. So the output would be like 10, 20, and after that is going to print 40, after that is going to print 60, after that is going to print 30. This is how it is going to print. Like for example, now there is 90, right? So this 90 would be printing after this 40. I mean after this coming here after 40, so it's going to print after 30. So this is how it's going to print. So let me show you an example in the code. After this it's going to print 30 here, 90. Till this part you hope you got it. After this the work is not done, so here it's going to be 90. Still this is not done. Let me, still there is going to be some swapping need to be done. 90. So this is how it's going to be done, guys. So what happens right now, 10, the shortest element came into the came to the top. So this 10 we need to remove it. After that this 90 is going to go to the top. So 90 and 20, which is small? 20. So swap with 20. 90 will be here, 20 will be here. This 90 and 30, which is small? 30. So swap it. So it should be 20, 30, and here it would be 90. Smallest element 20 is came here, so it's going to be removed. So now the 40 will be moving to here. So now thing would be, sorry, the 90 would be moving to here. So 90, 30, 40 and 60 would be there. So now if you check 30 and 90, let me show something like notepad. Now let me show you something in notepad, like instead of doing all this stuff, close this thing, don't say cancel. Minimize it. So if you see what happened, right, 10 is came out. After 10 came out, 90 would be moved to the top position, 90, and below it's going to be 90, and below going to be sorry, after 10 came out, right, 10 came out, 90 would be on top, that would be 20, and here is going to be 40, and after that this 20 is going to have 60 space 30, and this 40 going to have nothing. So now after this 20 going to swap to that 90 position. So 20 would be here, and here is going to be 90, swap it with 90, and we'll have 40 here, enter. Here is going to be 60, and this 30, this 20 would be 90 would be having the 60 and 30. 30 is small, it's going to swap up there. So here it's going to be now 30, and here is going to be 90. So if you see this 20 is small, so this 20 is going to come out of it, and this 40 is going to the top, sorry, this 90 is going to the top. So here it would be 90 now. Now after this here 30 and 90, 30 is small, so 30 is going to be on top, and this 90 going to come here. So after this 90 and 60, 90 is so big, so 90 would be swapped with 60. So when coming here, so 30 is small on the top right now. Now this 30 would be removed. Now 40 is going to move to the top. 40 is moved to the top, and 40 is having this 60 and 90. So now 60 is the, now 40 would be the smallest element is going to go out. Now 90 would be go to the top. Compared to 90 and 60, 60 is small, so 60 would be moved to the top, and it's going to be swapping the after that we are going to be left with one element. So let me show you the coding. Instead of this all priority queue, so let me remove this. I'll say priority queue. Sorry, O should be there, not P. Priority queue. Control V. Control V. Priority queue. I'll say we can put anything else, not an issue. I'll say here remove this all. I'll say here. I'll say 60. I'll say here 1000. Still I'll add some more things like 120. I'll say 420, 140, something like this. Enough. This should be more than enough. So I'll say AL and AL. Now I want to make 6 elements. Let me remove one. It will be big, or else it will take some more time. So here I'll say AL dot PEK, peak. Copy, paste. This is called pole. L4. Now if you run this code, get, oh sorry, I did not remove this remaining elements. I need these things. These are not required here now, but this one let me remove and let me run it. See, so what is at peak? 60 is at peak. 60 is at peak. So the smallest element is 60. Oh sorry, let me put here 160. It would be easy. So the peak element would be 80. The lowest element would be an 80. 80 is removed. Similarly, if you need to print like this, keep on printing peak using peak and pole. You need to write the code again and again until this. Peak and pole. Let's say peak and pole. Let's say peak and pole. Let's say peak and pole. See, 80 came out. After 80 came out, it is 100. From 100 it is 100 again. We'll say we get 120. After that we're getting 160 because we are using peak and pole. 420. The last one is 1000. This is how you will use this priority queue. After that pole, I'll say print ln. I'll say AL dot remove check what instance. So see, there is nothing. So there is nothing, no such element. So there is nothing to remove. So it is because it's empty. So 1000 is printing, right? Now so it's empty. See, at last it came empty. This is how you are going to use it. There are only 2-3 things like peak and pole. This one, and now peak will help you can perform only one operation. With the help of pole, we can perform 2 operations. And the method peak will give us only one element present in our queue. Pole will give us a first element present in our queue and remove that element from the queue. So hash set is next one. Is hash set is like What is hash set? It's heterogeneous. It's heterogeneous as well as homogeneous. It does not allow duplicates. It does not allow duplicates. Don't say it. Don't need it. So it does not allow duplicates. Does not allow duplicate. It allows null values. Its insertion order is not preserved because it follows hashing order. Default capacity is 16 and we can fill in the ratio of 75%. 75% of initial capacity will be filled with, it will be increased to double of its size every time. So I'm just saying because we need to discuss linked hash set as well, so that's the reason I'm just giving brief introduction. Let me show you a code now. Let me finish it quickly, or else this class will take a lot more time. Class should have all this thing. I'll say JS has asset as set. I'll say has set this 15 some value. I'll say some statement hello that contains, I'll say contains whether we can find it or not, say 80 dot size is empty and last one will say whether we will check real dot clear, same statement argument here. No read all these things now. So let me run the code. Sorry, need to close it. So it has set. It is taking or not? Java dot oh, has set S capital. Set, it should be S capital. Sorry, my mistake. Yeah. Every letter is important, guys. So here we are just adding values. Now whether we are checking whether it contains or not, and checking the size whether it's empty or not. These are some basic things, guys. This is how it's going to be hash set. Yeah, like linked hash set is is going to be for linked hash set it's going to be, because of linked hash set, insertion order is preserved. It's homogeneous as well as heterogeneous in nature. It does not allow duplicate values. Similarly, it allows null values. Initial capacity is 16 and full ratio is 0.7. And similarly, and I think this has, let me show you how this hash set works. Linked hash set works. LNKED linked hash set copy and paste. Same thing, is nothing much difference, it should be there. Let me run it. Wait, forgot to put that import statement. Let me reload it once. Now select all, paste it. Now control home, I'll say yeah, linked has set, right? Copy and paste it here, and let me run it. Yeah, similarly it's going to be like similar like I said, but like previous one, this is like linked has said, linked list plus it's going to be has said. Here insertion order is preserved. Similar it is going to be guys, and now there is something called tree set. It's going to be heterogeneous in nature. Insertion order is not preserved. We'll get output in ascending order. Duplicates are not allowed. No initial capacity yet. So and let me tell you one more thing, in this there is something like cursor, which means traversing. We can say cursor will more than will traverse will move from one object to another object. There are three types of it: iterator, list iterator, and enumerator. So let me put this linked has set, same thing, and let me import one more thing like copy, and I'll say something like say linked has set, sorry not linked has set, o dot util dot iterator say linked has set iterator itr equal to al dot iterator tr dot as next. itr dot next dot next next. itr dot has next dot has next. itr dot next next and has next. Let me print it. Oh, it's going to print. Cannot find the symbol, something is missed, I believe. al dot iterator, cannot find the symbol iterator. I think it should be small I. Iterator, yeah, this is how we put, right? So it's going to check first one has First we are printing that value, and next we are going to check has, oh sorry, first next one should be, first here it should be, yes, first we need to check, let me check here, there is some this next element is there or not. So et, let me remove this too, for 80 and let me print. Okay, has next is going to check whether we have next element or not. Let me run it. See what is happening here is, first, so first element is there or not, first one iterator, next it's going to print it. After this 160 there is another element or not, it's going to check, has next is going to check it is there, so it's printing true, it's printing 1000. Has next, there is a next element or not, there is an element after 1000, so it's printing true, it's printing the next element, that hello, and it's going to go to that has next element whether it's true there or not. After hello, hello, there is next element is 80, it's checking 80 is present, so it's going to print that value. Next, after that there is no element, so there is no element, that's the reason it's going to print false. After coming to the last element, it's going to print the false value. This is how this going to work. Now there is one more thing, like a tree set. Let me show you. Tree set. Instead of this link now, let me show. Yeah, I forgot to mention tree set value. Wait. Now tree set. We wrap it up quickly. Copy it, paste it here, reset, and I'll paste it here, reset, and no need this things all. Now, and I'll say 5. Now if I run it, so how this works is, first 160 is there, right? Here, these values, let me copy it, and here I'll say these values are there, right? So first is 160. 160 is going to compare with 1000, which is small. 160 is small, so okay. Next is going to come to 5, which is small. 5 is small, so 5 will move to the top and above 160, and now 5 is compared to 80. 5 is small, 5 is printed. After that this 160 is compared with 1000, which is small, 160. Next is go to 80, which is small, 80, so 80 is printed. After that it's going to check 160 and 1000, which is small, 160, so 160 is going to be printed. This is how it's going to work. This is how the sorting order going to work for the tree set as well. This is how this collection framework goes, guys. Hope you like the my videos. Yeah, thanks for watching. If you like my video, please like, share and subscribe to my channel if you are new to the channel. Thanks for watching.